Hello everybody. So today we're talking about soil erosion and control. So let's start off with just the basic definition. So what is erosion? Erosion is the process of detaching and removing soil materials from their original sites. So you've got two major causes of soil erosion. You have wind and water. Water is what we're going to focus on a little bit more today. In humid areas, water is definitely going to be your major cause of erosion. In semi-arid areas, it's going to be water and wind. And then in arid areas, because you know the big thing that makes them arid areas is a lack of moisture, it's going to be wind instead of water. And one thing that's interesting is that in terms of our different textures and our different types of soils, we find that soils high in silt are the soils that are most erodible. So our lands that we want to farm in, the ones that we really like for farming, are actually the ones that are the most erodible and the ones that are most subject to problems. So that's just something to really always think about in the back of your mind as we go through this lecture, because we're going to talk about the idea how we want to farm on these lands and all the different things that we have to do to try and minimize erosion, because one thing we know is we're not going to be able to stop erosion, and especially we're not going to be able to stop erosion because erosion is a major problem in soils that are high in silt, which are the ones we love to farm in. And the reason for that is just that silt acts as more independent particles and doesn't aggregate as much as the other soils do, and because of that, it makes it easily erodible. So let's start with water erosion and focus on water erosion. So we have two processes, detachment and transport. So we're going to focus first on detachment, and that's the process by which soil particles are moved from the soil mass. And so that's usually caused by raindrops on the soil aggregates, and basically the impact of the raindrops, the energy that the raindrop hits with is actually so much that it causes the soil to if we looked up close at it, to almost explode and to break apart into pieces. And the reason that this isn't usually a major concern or something that's problematic is that if you have plant material, if you have plants on top of your soil, then the plant absorbs the rainfall, then the plant gets hit by the rain, and the plant is structured better to deal with that energy, whereas the soil isn't. And so when you get rain, and especially if you get a lot of rain in a real short amount of time, you can get detachment happening, where you get the aggregate pieces breaking up and then being moved. And the process by which soil particles are carried away from their original site, that's the process of transport. And so transport really happens when infiltration is exceeded by rainfall. And so if you've got too much rain coming into the system so that the system fills up and can't infiltrate at a good rate anymore, then you're going to end up with surface runoff. And the surface runoff is what's going to cause erosion and is going to move the soil from one place to another. So we've got three types of water erosion that we're going to focus on. There's a couple more, but we're going to focus on three. So sheet erosion, so that's the removal of soil in thin layers without the development of channels. So where just a layer of the soil is going to come off. You've got rill erosion, which is the removal of soil through the cutting of numerous small but conspicuous water channels or tiny rivulets. And so when we say conspicuous water channels, we're saying usually less than 6 inches deep, so small water channels. Because big water channels, that's what we'd call gully erosion. And that's the removal of soil through the formation of relatively large channels cut into the soil by concentrated runoff, so by large amounts of water. And so anything that's larger than 6 inches deep, we consider that a large channel, and that's gully erosion. Side note, my last name is Arroyo, and when you get an English translation, that is dry creek bed that is subject to flooding, basically. So if you hear somebody talking about an arroyo, it's usually a empty riverbed or really a gully that can be subject to flash flooding due to being in an area where you get a large amount of rainfall in a small amount of time. So just a side little bit of information there. So here's just some examples of what we're talking about. So the idea of sheet erosion, we'll kind of start out with that one, and that's the idea of just a whole piece of the ground moving away or being moved out of the area. And then we have rill erosion. So if you see here, we've got a bunch of tiny little channels, and all those channels will be less than 6 inches deep. Whereas if we had gully erosion, we got a nice concentrated large channel that's full of runoff. Another look at it here, rill erosion, and then gully erosion. So you get just different looks at it. Let me slide myself out of the way so you can see this up here. But just the idea that you've this is really close up, where you moved bits and pieces of soil to where some are left, and a lot have moved on. So here's another look at it. So on the left here, you can see there's rills, and rills can then lead to gullies. So you've got small rills all over that area, and then it concentrates into that channel. And I mean, that is kind of how you form a watershed and rivers. It's just doing it through soil erosion. And then here's another example of rill erosion on the right-hand side here. So shallow drainage lines where water begins to collect in the form of depressions and begins to erode the soil. Now, if you're looking here and you're going, well, that's looking like more than 6 inches deep. Well, sometimes rills become gullies depending on the amount of runoff and water flow that they receive. So we got 5 factors that affect soil erosion by water. So those 5 factors are the climate, the soil properties, the slope, the surface cover, and the land use. And all 5 of those factors feature into what's called the universal soil loss equation. And the universal soil loss equation is used to estimate long-term average annual rates of erosion. And so these 5 factors are what really will determine just how much erosion you can expect in an area, and you can use the universal soil loss equation to really figure it out, because one thing that's going to be important to understand is you're not going to live in a place that doesn't have soil erosion, or you're not going to work in agriculture and not think about soil erosion, because it's something that is always going to happen. So we have to think about it, and we have to find our best ways to conserve soil and to minimize soil erosion. So let's kind of look in detail at those 5 factors. So climate is going to be your first one. And so climate is really dependent on, the biggest thing it's most dependent on is the amount of rainfall. And really you can say that as the amount of rainfall and the amount of time that rainfall happens in. Because you can see if you have an area like this, where you're obviously getting a lot of rainfall, and it's going to happen real quickly because you can see the amount of surface runoff that's happening, and your soils are full. Your infiltration rate at this point is very low, and you're getting nothing but surface runoff. So the amount of rainfall that you have and the amount of time that rainfall happens in. And then your temperatures, right? Because we talked about the idea of, is it a humid area? Is it a semi-arid area? Is it an arid area? So that's also going to play into it, and just the idea of, are we worried about water erosion or wind erosion or both? In terms of your soil properties, really the big thing to think about is the idea of water-stable aggregates. So we've talked about aggregation, and aggregates being the soil and the way the soil binds together to form, for lack of a better word, building blocks, and to work together and to be in a group of soil. And so what will really make that happen is your clay, your organic matter, but in terms of it really being water stable and being able to hold together while water is still within the soil, it actually comes down to the microbes, and I believe it's called glomalin, and that's basically this for lack of a better term, glue-like substance that the microbes in the soil are putting out to absorb the water and to be able to still kind of keep the soil particles glued together. And then it'll also depend on your infiltration capacity, because if you have really good infiltration capacity, you can deal with a lot of water. But you can see that the more aggregation you have, the more it'll make a difference. So if we look at this picture right here, you can see that the water, we've had soil erosion over here in this spot, but you can see there's certain parts where the soil didn't break away, and that's because you have better aggregation here than you had here. Or another way that it could have happened is that we just had more concentrated runoff here and not so much over here. But it's still the idea that these aggregates held together as opposed to broke apart. Your slope, your steepness of your slope, the length of your slope, and the shape of your slope. You know, if you're dealing with something like this, the idea of any sort of rainfall is going to be difficult. And if we want to farm an area like this, we're really going to have to invest in soil conservation methods, because it's very easy to lose a lot of soil and to have it all be going downhill when you have as steep of a slope as that. But certainly the steepness of your slope, the length of your slope, and then the shape of your slope, meaning the idea of, are we talking about like a really just a straight dive down, or where you got lots of contours and lots of little undulations on the way down? That sort of thing will make a huge difference in the amount of soil erosion. And then when it comes to surface cover and land use, we can kind of group those together. The big deal that really comes to play with soil erosion is just cover, and dense cover will prevent erosion. But when we're thinking about agriculture, or we're thinking about some of our uses of the land, we're not going to get dense cover of the land. And so when we're thinking specifically about ag, it's going to depend on the amount of surface cover and then the intensity of tillage that you do. So if you go in there and you chop up the ground and you open it up and you break up all those soil aggregates, which is really good for plant roots to get in and really easy for seeds to get into the ground, but also is going to create more soil erosion. And so it's really important to understand the amount of surface cover you have, as well as the intensity of the tillage that you're doing. So one of the things that is the kind of the next step in soil erosion by water is, we talked about the idea that you got detachment, so it gets separated from its original site. You got transport, so it gets moved from its original site. But then, of course, if it leaves its original site and gets put somewhere else, it's got to end up somewhere. And so that's what sedimentation is. It's the process of depositing erodible soil material wherever it ends up. And the finer the particles are, the farther they're going to get carried each time. Now, what's interesting about the idea of sedimentation is it can be a positive and a negative. So if we look at two examples here from the southeast, so on the left here, I think this is what most people think of when they think of sedimentation. They think of the idea of there's our nice Chattahoochee River there by the city of West Point, Georgia, and you can see this is the city of West Point drinking water intake, but you can see how brown that the Chattahoochee River is at this point in time because of all the sedimentation from soil erosion going into the river, and that's not great for that drinking water intake. You're going to have to filter that water quite a bit to make it potable. Whereas on the right here, this is an example of a loess bluff. And what loess is the idea of of soil erosion that happened where this is in the lower Mississippi alluvial valley, along the lower part of the Mississippi River, and so much soil was moved downstream that it actually piled up and made these hills. And so even though you drop off into the Mississippi Valley, at one point in time, you're going to drop down into the Mississippi Valley and you think, I'm going to just keep going down and down until I get to the river. But then you actually hit these hills, and these hills have developed due to soil erosion. And so sometimes, and not always, and it's definitely more so a negative than a positive, but sometimes there are positive effects from sedimentation. And why? Well, it formed hills, so why is that a positive effect? Well, those hills are some of the best agricultural land that is out there. It's really fertile soil. It's a good soil. And so that's actually a positive for the people in that area. So let's talk a little bit about soil erosion by wind. So soil erosion by wind is going to be especially severe during drought or especially severe in arid areas. And the way particles move by wind erosion is through the process of saltation. So saltation is the process by which particles particles that are moved by the wind do a series of impacts and jumps where they basically bang into each other, and then that banging knocks the next one into the air, and just trying to get it to basically jump all over the place. And so if you look at this picture on the left, this is an actual example of the paths that these little particles are taking as they kind of bang into each other and kind of jump or do saltation along the surface. And so then here's some other examples. So here's some more examples of saltation. You also have what would be called surface creep. So creep is where the particles just kind of get pushed along the surface. They don't leave the surface the way they do in saltation, where you get kind of the little jump and impact being pushed by the wind. They just kind of get pushed by the wind and kind of like roll along the surface. That's what creep is. And then you, if you have really fine particles, you get suspension. So you get little particles that are up in the air and then stay up in the air because they are suspended up in the air. And so one of the biggest events where we saw wind erosion was the Dust Bowl in the 1930s. And so there's a little video that I've attached right here on the left. So go ahead and open up the notes and pause the video and pause this video and then take a look at that video. And so the Dust Bowl happened in the 30s, and due to a historic drought and due to farming practices that weren't quite refined at the time, or not the most soil conservative practices, you end up with this hugely affected area within the U.S. In fact, felt all the way as far as Washington, D.C. with suspended sediment, suspended particles being up in the air and kind of, choking people out and basically forcing a lot of people to leave. Also, interesting side note on the Dust Bowl, some of you might know this because of your families, but a lot of people ended up in the Bakersfield area because of the Dust Bowl and having to move out of that area and then wanting to find another area where they could go and make a life and farm, and they ended up in the Central Valley down here. And so it's just it's our best example of wind erosion and the real severe problems that can happen from wind erosion if you don't know how to conserve soil. And so let's talk about the idea of normal soil development, because it's really important for the next part that we talk about. And so when we're talking about the best medium for plant growth, so our best version of soil, we want plant residues to accumulate on the top of the soil. That becomes our organic matter, our O layer, and then it's going to decay into the soil. And that O layer is then going to accumulate into the A layer, into our topsoil. And it's going to create a really nice, friable structure that's going to be easily penetrated by plant roots, water, and air, which is what we want, because we want our pore spaces filled by water and air, because our perfect soil is half water and air, and then minerals, and then organic matter. Your clay then is going to wash down farther into the profile, and it's really going to settle a lot into the B layer. So your subsoil is going to become denser and more resistant to root penetration, and it's also going to become heavier, and it's going to become a water retentive soil layer. So it's going to really hold water really well. And so that's our perfect version of soil. And so now, knowing our perfect version of soil, now we really have to talk about soil loss, and then we're going to talk about our conservation practices. And so when we're talking about soil loss tolerance, we have to understand that it's impossible to cultivate land without losing soil. We cannot use the land without having to deal with the loss of soil. It's just when we're talking about soil loss tolerance, we're talking about the amount of soil loss that can be tolerated each year while still maintaining high soil productivity. So for most croplands, that's around 4 to 5 tons per year, which is pretty substantial. 4 to 5 tons of soil lost per year. And so that really gets us into the idea of soil conservation and thinking about the idea of how do we actually conserve soil. And so one of the easiest ways to think about conserving soil is the idea of sustainability. Well, so if we're trying to sustain soil, then we have to be creating soil just as much as we're losing soil. That's an easy way to be sustainable. And so when we look at it, currently, we're losing soil at about 10 times more than we are creating soil. So soil formation and the pace that soil formation's at, which we've talked about before, is a really slow process for soil to develop. So currently we are losing, because we're losing 4 to 5 tons a year on average in these croplands, we're losing 10 times more soil than we are making. And so if we're really trying to conserve soil, that's the first thing that we've got to think about, is that we are losing, because of soil erosion, so much more soil than we're creating. And then we really got to think about our practices and how we could change our practices or better our practices to prevent this from happening. And so one of the things we can think about is, how do we reduce detachment? And so one of the biggest ways to reduce detachment and keep our soil in the spot where it's supposed to be is to reduce the force of raindrop impact on the soil. And you can do that by keeping the soil always covered with plants or plant residues, because those are going to absorb the energy of the impact. And so in farming, how do we make this happen? So you can grow perennial crops like hay or pasture, where you're just going to have surface cover at all times. If we're in the crop harvesting, crop rotation sort of a thing, we can leave crop residues on the surface, and then grow our next crops within those. And we'll talk about how you do that. And then growing winter crops and doing once your summer crops are done, then we start with the winter crops. When the winter crops are done, we're back to the summer crops, or maybe you're a winter, spring, and a summer crop kind of grower. But the idea that we always have something on the surface is going to prevent detachment from happening. In terms of reducing transport, we're trying to decrease the amount and velocity of the runoff water, because it matters how much runoff we're seeing, but it also matters how fast that runoff is going. So we want to increase infiltration. And so the ways we can increase infiltration is to have good soil structure and create large pores, and making sure we have large pores and large healthy soil. So one of the big things we want to avoid is soil compaction, because if soil gets compacted, soil gets squished down. And if it gets squished down, you don't have pore space, because that's what's going to disappear when the soil gets squished together, is that pore space. So we want to make sure we have good soil structure with large pores and small pores and lots of space for air and water. Organic matter, plant roots, and earthworms are all also going to be helpful in the process of creating large pores. organic matter is going to add into the process and help aggregates form. Plant roots are going to then work their way through everything, and by working their way through everything, they're going to open up space and open up room for pores. And then earthworms are also doing the same thing as they're digging through the soil. And then we've got all sorts of other methods that we can use, that we can see down here, that are also going to be ways that with human intervention that we can try and control soil erosion by reducing transport. In terms of controlling wind erosion, it's still the same thing, the idea of soil being covered at all times. The more we have our soil covered, the harder it is for the soil to get up and go. But another thing that we can do if we're in an area that really is problematic with wind is we can create windbreaks like we see in this picture on the left. And so windbreaks are the idea of planting trees or shrubs or something larger than the crops that we have in between our fields. And usually you want to do that perpendicular to the wind so that the wind has to hit it and basically has to lose energy by fighting its way through whatever barrier you've used as a windbreak, whether that's shrubs or trees or whatever. And you might sit there and go, well, yeah, but wind goes through trees. It does, but it loses a lot of energy. A lot. The majority of its energy is lost by the time it gets through to the other side. And that means that windbreaks are extremely effective at controlling wind erosion. In terms of soil management systems, there's we kind of showed a few things before, but there's all sorts of different ways and different methods of intervening that we've come up with. So let's just focus on a few of them. And so conservation tillage in terms of agriculture is hugely important. So when we talk about conservation tillage, we're talking about any method of cultivation that leaves the previous year's crop residue on fields before and after planting the next crop. And when you do this, you're going to reduce soil erosion and runoff. Well, bingo, that's fantastic. That's what we're looking for. How do you do this? You got to make sure that at least 30% of the soil is covered by crop residues, and in some places they'll go up to 70% of the ground being covered by crop residues. And your benefits, greatly going to reduce soil erosion. You're going to improve your soil and water quality because you're just adding organic matter into the soil. You're going to conserve water and energy. You're going to provide food and cover for wildlife, and you're going to reduce air pollution and soil compaction just because you don't have to make as many trips because you're into the field, because you're not tilling as much or having to do as much in the field. And so because of that, you're saving it's not on there as well, but you're saving money too because you're just not having to work as hard. Well, that sounds great. So what are some examples of conservation tillage? So you have no-till, which the farm that I get my vegetables from is a no-till farm, and that means planting crops directly into the residues that haven't been tilled at all. And so you can see a good example of that here, where you still see all the plant residues on the ground, which is perfect because the soil is not going to pick up and go, and that organic matter is basically going to act as a mulch, and it's going to keep water in there, so the soil is going to have this great source of water. It's going to add organic matter into the soil. It's just so perfect and so beneficial for soil. You can also do strip tilling, which you can see is almost the same thing, but it's only been tilled in narrow strips, and the rest of the field is untilled. And then you also have ridge tilling. So you're going to plant row crops in these permanent little ridges, only about 4 to 6 inches high, and then you're going to take all the crop residues and put them in between the ridges. And so then you're going to basically get all the same benefits, but it's just going to be kind of adjacent to those areas as opposed to being planted right in those areas. And so the previous crop's just going to be in the furrows in between the ridges. And then just the idea of using cover crops. And so if we're not comfortable with the idea of cover crops, that's a crop grown between periods of regular crop production to prevent erosion while providing environmental benefits. Like what? It's going to prevent erosion. If you use legumes, you're going to trap and produce nitrogen. You're going to build soil quality just because you're adding organic matter, more organic matter into the soil, more plant roots, all that sort of stuff. Better off we are. You're going to conserve soil moisture because, like I said before, if you've got plants on the soil and plants going into the soil, it's basically going to act as a mulch. You're going to suppress weeds from growing in those areas. You're going to recycle more nutrients, and you're going to enhance wildlife habitat. Fantastic. All really, really good benefits. Buffer strips. Buffer strips is another way that we can help out. And so buffer strips, permanent vegetation that's going to be located between ag fields and the streams that they in which they drain. And so these buffer strips are going to filter sediment as well as absorb nutrients and deactivate pesticides. So as pesticides work our way through the system, the buffer strip is going to really deactivate and take out a lot of the harmful parts of the pesticide because of the different. Now what's really important is that you use differing vegetation within your buffer strips and different types of vegetation so that you have all these different trees and shrubs and grasses and whatever else with all these different, for lack of a better word, amenities or skills in which they can help with deactivating pesticides and absorbing nutrients. And ultimately, the one place to really end this lecture and really get you guys to think about it is soil conservation is the responsibility of all who use it. And so if we want soil and if we want healthy soil, we've got to think about soil conservation. We've got to understand that, yes, we do need crops and we are big supporters of agriculture, but we also have to start finding ways to do it better and ways to make sure that we can still deliver a great product while also conserving the soil, because we don't want the soil to ever run out, because we know the importance of the soil. And so soil conservation is the responsibility of all who use it. And so hopefully you got a little bit about erosion. Hopefully you got a little bit of how we can fix it. And hopefully you're one of these people who is going to be responsible for soil conservation.